Good morning, good afternoon, and good evening from whichever location you are watching this video. And in this video, what are we doing? In this video, we will go and we will try to understand solid principles. We will run through some important questions around solid, right? But before I start with this video, right, if you go and if you share this video anywhere, in your LinkedIn, only LinkedIn, right? Only LinkedIn. If you go and share this video on your LinkedIn and if you tag me, this is my LinkedIn ID, right? If you tag me, I will give you this architecture interview questions ebook for free, right? So what you do is that share this video out there, send us an email saying that this is the link I've shared, right? And we will give you this nice architecture book, which covers MVC, MVVM, how to answer your project, singleton pattern, solid principles, repository pattern, factory pattern, और क्या चाहिए भाई, right? So go ahead, share this video, right? Okay, so very quickly now, again back to the topic, right? So first thing what we'll do out here, one is, if you look at solid principles, these are the questions, which are asked in the interview around solid principles, right? What is solid? Explain Liskov. Is there a connection between Liskov and ISP? They will also talk about inversion of control, dependency injection, because they are all connected, right? But before we go to these 20 questions which are asked in the interviews about solid, first what we'll do is we will try to understand the concept of solid. We'll go through some sample code. We'll try to understand the concept of solid. And at the last of the video, I will run through all of these questions, right? So this is the plan in this video. We will first understand the concepts, all the 5 letters, what they do, go through the sample code, and then finally we will go and run through the questions, right? And don't forget, if you go ahead and if you share this video on your LinkedIn or anywhere out there, right, on your LinkedIn, only on LinkedIn, and if you tag me, you get this nice ebook, out there, which is almost of 30-40 pages out there. So let us start with the first letter of solid, S, single responsibility principle. So what does single responsibility principle says? Single responsibility principle says that one class should do only one thing at a time. For example, you can see that over here, we have an employee class out here, and this is an employee ID, this is an employee name, the type of employee. Type of employee means manager, helper, team lead, and so on, right? And there are a couple of actions, which we have put in the employee class, calculate salary and the task what the employee does depending on he's a manager or a helper and so on, right? Now, look at this class and think for a while, right? Think for a while. Okay, so to this class, right, what it should do, it should take the employee name, absolutely. It should help us to identify that he is a manager or a helper or a team lead, absolutely. He should do a task, absolutely. Calculate salary. This is the odd man out. Think about it. You see an employee in your company. Does he calculate the salary? No, I don't think so. The calculation of the salary is done by the account department. So that means that this class is now doing some unnecessary work. And if you start loading a class, with these kind of unnecessary work, right, at some moment of time, your class can become a God class. A God class means a class, which just starts becoming bigger and bigger unnecessarily, right? So what single responsibility principle says, this salary calculation is not the work of the employee class. Create a separate class for this, right? So that is single responsibility principle, right? So what I'll do out here is I will go ahead, I will create a salary class, a salary calculation class must be like this. And I will say that this calculate salary is a part of this, right? And we will go and we will pass the employee class to this, right? So we'll pass the employee object to this. And depending upon, who the employee is, right, he will actually go and calculate the salary. So this is called as SRP, single responsibility principle. One class should do only one thing at a time. The employee class should look only into the employee thing, like the name, type, do task, right? But salary calculation, should be done by some other class, right? Single responsibility principle. One class should do only one thing. And if it is doing multiple things, you need to break that class. Now the second letter, right, the second word from solid is O. O stands for OCP, open close principle, right? What does open close principle says? Open close principle says that rather than modifying the class itself, try to see that you can extend it, right? In other words, what we say is that the class should be opened for extension. It should be open for extension, and it should be closed for modification, right? So in other words, You can see that this is salary calculation class here. So I'll say here, okay, if the employee type, right? So let us say I write a logic out here. If I say employee type is 1, which is actually a manager, his salary would be X. Now remember, a salary calculation will have a lot of logic out here. At this moment, I'm just returning a value out here saying 20,000. Okay. And you will say, and else if, right? So else if, right? If the salary type is 2, right, then probably I would return, let's say 10,000 because he is the team lead. Okay. Or else if he is a helper, I will return something else, right? So you can see out here, or else if it's none of them, then we just return a 0. Okay. Now, if you look at this code out here, what we are doing is that when a new type of employee is added, you go and you change this salary calculation. Please listen to my sentence, what I'm saying. When a new type of employee is added, what you will do is that you will go and you will change this method calculate salary, right? So in other words, if you get a new type out here, must be, let's say you get, something called as a supervisor. I'm just saying. So you'll say, okay, else if 3, and you will say his salary is 5 or something, something like that. Okay. That means what? You are actually modifying the same code, right? Now, what is the problem with this, right? What is the problem with modifying the same code? Let us say that this salary calculation, assume, think for a while, close your eyes and think for a while, that this salary calculation is used in hundreds of places, right? So for what I'm trying to say is that you can see that this is my MVC application, and just try to visualize, for a while, saying that the salary calculation is used here, right? X is equal to new salary calculation, right? It is used here, it is used there, it is used in customer controller, it is used in home controller, it is used in thousands of places, right? Now, if you go and if you change something in this class out here, and let us say if there is a bug or if that leads to side effects, what will happen is all of these 1,000 places will get affected. Again, let me repeat this sentence, right? You have a class and that class is used in multiple places in your project, assume, right? And if you go and if you change something out here, then you have to make sure, you have to do all the unit testing, you have to check for everything, because if something goes wrong out here, then what will happen is it will go and affect all the other places from where this class is called. So what OCP says is that, OCP says that rather than modifying that same class, right? Because if you modify that class, it's going and it is affecting everywhere, right? Actually in Hindi, there is a sentence which is very famous, right? Which says that, chalte hue kaam ko nahi bigadna hai. Means if something is working out there, let it keep working. Right? If you change something over there, then it affects everything, right? So if you like that sentence, then please put down on the comment that you like that sentence, right? So here it is. So what we do out here is rather than going and changing the existing class, we go and we use inheritance. So what we do is that we say, okay, let's make this as virtual, right? And we'll say that this calculates salary, calculates a base salary out here. And then we'll say, okay, now what we want to do? We want to go and add a manager, right? Okay, so we go ahead. We create a new class, open for extension and closed for modification, right? So I will go and I will say, okay, salary manager calculation, right? Extend salary calculation. And then what I'll do is I'll go ahead and say calculate salary. And over here, I'll say that the manager's salary is something 20,000. Now, please note out here, I'm putting a single value like 20,000. So normally salary calculations are not so straightforward. You will be calculating his taxes, you will make some call to an API, right? So think about it, there would be not, it's not going to be like return 20,000, right? You are going to go and make a call to SQL server and something, right? So there will be a lot of code out here, which will be from, you will calculate his holidays, you will calculate his leaves and so on, and then this value is returned, right? So now, whoever is using salary calculation, let them be happy, right? But whoever wants to use the new salary manager calculation, the manager calculation, they will only go and change this to salary manager calculation, right? So in other words, what I'm trying to say is that with open close principle, what happens is that you don't change the existing code because that code can have a lot of references out there, right? And with that, there will be a huge impact analysis. And you create new classes, and whichever new clients want to use these new classes, they should be happy with this new class, and the old clients don't get disturbed. OCP. open for extension and closed for modification. Now let us talk about L. Now, out of respect for the L, what I will do is I'm going to go and close this computer, right? I'm going to go and bring down this specs out here. You know why? Because this L part is the most, I'll not say the toughest one, the most weirdest one, right? So what we'll do is, for now, I want to move out my face from all this and I want you to focus only on the code, right? Because what I've seen is that the S and the O, many developers talk about it. If you just say S, they will just speak like that. If you just say O, they will speak like that. But when it comes to L, right, like everybody just, somewhere the words get lost, right? So what I'll do is, let us go and focus on the computer, right? I will focus on the computer, you focus on the computer, and let us understand the L part of solid. L stands for Liskov Substitution Principle. Let us have a look at it. Very quickly, before we go to the next module, before we go to the next lesson out here, I have a quick announcement to make here. On questpond.com, we have live trainings, which are on Azure, which is happening on ASP.NET MVC, on Angular, on React, on business intelligence, and a lot of topics out there. So if you're really interested, please go and visit questpond.com, which I'm flashing on the screen. At the same hand, we have some other developers out there who will say, no, I don't want a live training. I wanted recorded videos. I will do it myself. I want interview preparation videos, right? So in the same way, we also have architecture interview preparation and Azure interview preparation and, MVC and so on, right? So please do go and have a look at it once, right? So do visit questpond.com. And now let us move to the next topic. Let us first understand what Liskov substitution principle says. Actually, if you go on the internet, right, and if you try to search for Liskov, you get these kind of definitions, and these kind of definitions are very, very tough to understand, right? So let me try to put it in a simplest manner. What Liskov substitution principle says is that it says that the child class should be able to implement all the methods of the parent class seamlessly and smoothly. Means what? So you can see that we have a simple employee class out here, right? So now let us say you have, your internal employees. So you'll say, okay, we have our internal employees and all the employee inherits from this employee class out here, right? Or you'll say, okay, I have a manager kind of employee, fine, manager employee out here, who again inherits from the employee, and must be a manager does task, which is a little bit different, right? He does a management activity, so you override it, right? And so on. So you can go and inherit from this employee class and create different types of employees out there, right? Now, let us say you have an employee which is on contract, okay? So again, you'll say, okay, a contract employee, right? Okay, a contract employee looks very much like an internal employee. He has an ID, he has a name, he has a salary, and so on. He will do some tasks, right? So he'll say, okay, that looks pretty cool, right? And he will say a public class, a contract employee or a vendor employee will also inherit from the employee class, right? Okay, and you will say, yes, he will have its own task, so we'll override it and so on, right? Now what's happening out here, right? Now, if you go and if you try to use the employee class, so let us say I'm trying to use the employee class here, right? So I'll say, okay, I want to go ahead and create an internal employee, right? Fine. So internal employee E, right, equal to new internal employee, right? And you will say, okay, E dot name, pretty much good, like Shiv, right? E dot salary something, so E dot yes, employee also gets a salary and so on, right? So yes, whatever is a salary. He also gets some health insurance, fine, this also looks cool, right? He also gets some health insurance out there, right? So now in the same way, you go ahead and you create an object of a contract employee. You say yes, contract employee has a name, contract employee has a salary, but contract employee does not have an insurance. Now that is a problem, isn't it? How do you get rid of this insurance, right? Now, one of the ways many developers would say is that just keep it as it is, right? Just let it be there, right? Well, that is one way of thinking. You can say, okay, let it be there, right? But that will confuse, the developers who are using your component, who are using your class, isn't it? So definitely that is not the clean way. Or some other smart developers do like this also. So they will go and say, okay, let us do like this. Let us go ahead and create a propful, something like this, which we will say decimal of underscore insurance or something like this, or must be we'll just go and create an empty property out here, something like this, like an insurance, right? Whatever it is, insurance, health insurance, I'm sorry, fine. So we'll go and create a property called as health insurance, right? And very smartly what people do is, they just go ahead and say here, well, throw new not implemented exception. Fine, that is one way of doing it. In the same way you can do it for the get as well, right? So this is here, and then in the same way in the set also you can go and you can do something like this. Now again, not a clean way of doing it, but as we can just go and say like throw new not implemented exception. You can give a good message here saying this is contract employee not allowed, right? But again, this is a hack, isn't it? It's not a clean way of doing it, right? Right, so this is what is termed as a Liskov problem, because in inheritance, now listen to my sentence properly. In an inheritance, you cannot subtract. I cannot go ahead and say remove the health insurance, this health insurance property out here. Remember, it's health insurance, right? Actually, the way it should happen is you will actually go and say this is virtual, and you will go and you will override it. That's the right way of doing it, right? So yeah, so whatever it is, you override it, or I was doing shadowing actually previously, right? But the point is that this is definitely not the clean way. That is one part, right? And the second important part, what I'm trying to say is that there is no way I can subtract this health insurance property or even the methods of the parent class in the child class, right? So what is the solution, right? The solution is that you have to go and create two different kind of employees. Your abstraction has gone wrong out here. Must be your requirement. Normally, when the Liskov problem happens, the requirement is not taken properly or misunderstood, I will say, right? So what really should be done out here is you should actually have a base employee, right? You should actually have a base employee first, right? Saying that, okay, here is a base employee class, right? A base employee class, right? And the base employee class will not have the health insurance, right? He will have everything else. And then you go and say, okay, now we have different kinds of employees. So must be you can go and you can create an internal employee, right, who inherits from the base employee. So he gets everything, right? And he also gets the insurance. So he'll say, okay, this is all there, but here we have something called as extra thing called as the insurance out here like this. Okay. And then you can say, okay, so what about the contract employees? Well, the contract employees will go and inherit from the base employee, right? And that looks pretty cool, right? That looks pretty cool and neat, right? So in other words, you have to change it, from the root. So remember, what happens in a Liskov problem is that when your project has gone too ahead, let us say that you have started your project, and then let us say after the third or fourth month of your implementation, you come to know there is a Liskov problem, right? It is very difficult to solve it because you have to now go and change the base classes because your abstraction has gone wrong. So remember that Liskov problem is not understood in the first go, right? Because it can be so misunderstood, right? Because of the requirement mismatches or because of the requirement misunderstanding. So you come to know very late about the Liskov problem, and until that time, many of the child classes has already implemented the base class, and you can't really revert back, right? But the real solution to this problem is that you have to go and change your base class, right? You have to go and differentiate between the internal employee and the contract employee out here, right? So now then it looks pretty cool. Now you'll say that there is no insurance. That is good. So contract employee does not have insurance, but an internal employee has an insurance, right? And one of the famous saying of Liskov principle is that it looks like a duck, it quacks like a duck, but it has batteries, right? In the same way here also, this looked like an employee, right? This looked like he did task like an employee, right? But he does not have insurance, right? So that is a Liskov substitution principle, LSP. So as we are learning these new terminologies and new concepts, I think one of the things we should do as a developer is that out of respect, we should at least know the names of the developers who have coined these concepts, and because of these concepts, we can see that how we as a programmer have grown, right? So here's a small quiz, right? And if you can answer this quiz, not only we are respecting them, also we are getting knowledge about it, right? So put down in the comments who has thought about Liskov, who is the creator of Liskov, right? And let me give you a hint. It is not him, it is her, right? And the second question is that the person who created Liskov, right, has created two programming languages. Write down in the comments which those programming languages are. Now the next letter out here from solid is the I, right? So we single responsibility principle, O open close principle, L Liskov substitution principle, and the I1 is the interface segregation principle. What the interface segregation principle says that any code should not be forced to use methods which is not needed, right? So if you have a client out there and he does not want some methods, right, you are still providing him that methods, right? Then that means that, there is a problem, right? So in other words, let's see an example out here. You can see here I have created something called as iCRUD, right? This is a repository out here, and this iCRUD can be used, to add, update, and read and delete and so on, right? So all the CRUD operations you can do with this. Now let us say in the home controller you want to go and insert, update, and delete, right? So it makes sense to use iCRUD. It makes sense to give him all the methods like x.add, x.update. You can see here all the methods out here are accessible out here, right? For accessible here, and he needs it. This client code needs all the methods because he is doing a full CRUD, right? But now let us take another example of the reporting control. The reporting control is where you only display data. That UI does not need to insert, update, and delete, right? But because you have only one interface, this code, the reporting controller code, or I will say the reporting controller client, is still forced to reference these methods, which is like add, update, and delete, right? Even though he only needs the read, but because everything is into one interface, it is not happening, right? So what interface segregation principle says is that segregate the interface, right? In other words, what it says is that go ahead and create an interface which is called as iRead, right? So go ahead and create an interface here called as iRead, and we go ahead and we put this read out here. And we say that iCRUD, I will not use the word inherit, but I'll just say that iCRUD will go and use iRead as well, right? So iCRUD is iRead plus his own methods, right? Okay, you can think about this like interface inheritance, okay? Because when you say interface, using the word inheritance does not make sense. It is always like interface are implemented, right? But in this case, it is safe to assume that this interface has been inherited, right? Okay, so now here, what happens is now this home controller will use iCRUD. He will get add, update, read, everything, and the reporting controller will only use iRead. You can see now he does not have access to update. He will not have access to add. He will have only access to read, right? So this is what interface segregation principle says. It says that the client code should not be forced to use the method, right? And how do you do it, right? You actually go and split the interface. You segregate the interfaces, right? Depending on what the client needs. ISP, interface segregation principle. Quiz, right? So here is a quiz. Here's an incredible quiz which I'm putting forward. So this whole solid acronym, who is the creator of it? Let me give you a hint. He is an incredible Angal, right? Okay, so please put down some dazzling, mesmerizing comments about this incredible uncle out there, and let the developer community know who has created Solid and what are the other achievements our incredible uncle has done, right? And the last letter is D. D stands for dependency inversion. DI. Remember, not dependency injection. In interviews, what I've seen is that sometimes developers do these kind of vocab mistakes. For example, what is I in solid? They will say IOC, inversion of control. What is D? Dependency injection. No. Try to see that you say the acronyms right, because think about it. If a senior is not knowing the acronyms, right, it's a problem, isn't it? You right away get rejected, right? So just make sure that you are aware of the acronyms and you are aware of the concept. Inversion of control and dependency injection is almost in line with dependency inversion, right? But it is quite different, right? So, but here now let us focus on dependency inversion. So what dependency inversion says is that, so the higher level module should not depend on the lower level module directly, but rather it should depend, or it should access it through an abstraction, which is nothing but an interface. I repeat this. Dependency inversion says that higher level module should not depend on the lower level module directly. They should talk through an abstraction like an interface, right? So here is a sample code. Let us try to understand, right? So you can see here, first let us try to understand what is higher level module. So you can see this is home controller, and the home controller is using the internal employee and contract employee. So the home controller becomes the higher level module, and the internal employee and the contract employees become the lower level module. So now, what is the problem with this arrangement, right? The problem with this arrangement is tight coupling. Tight coupling in the sense it is not a loose coupled architecture. Means what? For example, tomorrow if I want to go and change this internal employee to something like a manager employee, right? Then I have to change in so many places out here, right? So rather than going and directly referencing the concrete classes, rather than going and referencing directly the directly the lower level modules, right? How about we say that, okay, this is the home controller, and he says that like I'm going to go and refer only I employee, so an interface. So in other words, what we have to do now is we have to go out here to the employee class and first create an interface. So we'll say, okay, public interface I employee, right? And we will say that all these things are common in this interface. Remember, in an interface, we don't have to do this public thing out here. So we'll go and delete everything public out here, right? So everything is deleted, right? And right, so this is an interface, right? And all your classes down below will implement this interface. So now this is the I employee, and this, so now this home controller, rather than going and saying at the back end, there is a contract employee or internal employee or a manager employee, he will say that I will just refer I employee, right? So now you can see this home controller is not directly referring the concrete classes internal employee and manager employee, but it is referring it through an abstraction, which is I employee, right? And then you can use dependency injection. Now I will not go into what is dependency injection, right? But you can say that, okay, I don't want to refer this, I don't want to get into that concrete classes like contract employee and this employee and that employee. Somebody please inject this I employee from the top, right? So, and I will just get that instance out here, right? Now you can see here, this code out here has no reference. It has no reference at all to the concrete classes, to the to the concrete classes, to the final classes out here, right? So, or to the lower level modules. So higher level module should not depend directly or should not access the lower level module, but it should access through abstraction, through an interface. So that is dependency inversion. So now that we have gone through all the code out there, we have understood solid right now. These are the 20 or 20 plus questions. I don't know the numbers out here, but these are almost 20 questions out there on solid, right? Let us go and quickly revise it. Remember that all of these questions I've taken from an architecture interview preparation course. So Please go to questpoint.com. We have live trainings happening on Azure, on MVC, on C#, on MSBI, on a lot of topics out there. Also, we have interview question course and standard step-by-step video courses. You can also see that, right? So very quickly, let us go through that. And don't forget, yes, if you share this video, you get this beautiful ebook for free, right? So here are the questions. What is solid? We have already talked about it. S stands for single responsibility. O stands for OCP, open close principle. Liskov, interface segregation principle, not IOC. Dependency inversion, not dependency injection, right? Okay. Explain SRP with an example. So we have seen that one class should do only one thing at a time. We have already talked about it. Explain OCP. So the class should be open for extension and closed for modification. That also example we have seen, right? Liskov problem. The child class should implement all the methods and properties or whatever of the parent class seamlessly without any side hacks. That also we have seen. And how can we fix the Liskov problem? You have to fix it from the top. You can't fix it somewhere like a hack, right? Interface segregation principle. The client should not be forced to depend on methods which he does not want, right? That also we have seen. And a higher level module and a lower level module and dependency inversion. 38th question out there, that also we have seen. And higher level module should not depend directly on the lower level module, but it should depend through an abstraction out here. And remember, whenever we are talking about solid principles, inversion of control and dependency injection are very connected, right? Very, very connected. So again, that topic, we have not taken it out here. I would suggest you to practice, or you can go and take our interview question course where we have explained all this, right? And in interviews, what can also happen is, they will ask you some confusing questions like, what is the difference between Liskov and ISP? Because they look very similar, right? In Liskov also we try to break things. In ISP also we try to break the interfaces, right? But remember, they are very different, right? So this is the questions out here, right? I've just tried to cover from the top, right? If you want to get the actual answers of this, please go and share this. We have the ebook. In ebook, we have answered all the questions. Or avail to our course, right? In our course, I've explained this in very much detail, right? Once you go through my solid principle course, which is internally, right, of interview questions, you can handle any kind of cross questions, right? So that brings us to the end of this video. I hope that you have liked this video, right? And below also I have pasted all my other videos like C# interview questions, architecture interview questions, which kind of design pattern are asked in your project, right? Please go through them. SQL Server interview questions, ASP.NET interview questions, Angular interview questions, also step by step. So please see on the down links out there. So happy learning, happy job hunting. I hope that next time you get solid questions, you should be able to handle it. Thank you.